All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue. Um, we're going to continue learning how to create websites using Zola. Yeah, that's what I was trying to say. Today we're going to continue learning about Zola, um, picking up where we left off yesterday. Because after yesterday's stream, I didn't really do too much Zola studies because I got busy doing some other research. Dude, I have this idea that at some point later I might execute it. I don't know. I'm definitely gonna need a good amount of knowledge in Zola, in Nano, and in Dioxys in order to be able to execute this idea. But if I'm able to do it, I think I'm going to be able to make a pretty nice looking website, and a lot of the heavy lifting for the aesthetics will be done through Nano, and there will be a Dioxys app in between Nano and the web page in order to handle data transfer. That Dioxys app is going to be acting as a bridge because Nano isn't really meant to interact with your web page. So while you could technically do it, it would be a little complicated. You would have to write some JavaScript stuff and somehow interface between JavaScript and your Rust code, and things can get a little bit complicated there. Where was I going with this? Yeah, Nano is not meant to interact with the web page, but Nano can do a great job of handling aesthetics because that's what it's for, right? Dioxys, let's just say it's not meant for aesthetics. You could make good looking UI, but there's definitely going to be a limitation to what you can do with Dioxys. What Dioxys does excel at, being a web application framework, what it does excel at is interacting with the elements in the web page. You can actually use your Dioxys app to interact with the elements of the web page. So that is why, and because I want to avoid touching JavaScript, and I want to stay within the Rust ecosystem as much as possible. So I was like, okay, let me learn Dioxys. Let me then also learn Nano, because I'm anyways planning on learning Nano. So let me do that, and then um, where was I going with this? I was saying that yeah, let me learn Dioxys and Nano, and then I can like I forgot where I was going with it. But yeah, I'm gonna use Dioxys and Nano. This is for a future project, and I need to stop doing research on this project now because I seem to be spending a lot of time in it. Okay, I have this thing which I wrote. Current focus. I said learn and explore so and so. Okay. Learn data science through Kaggle courses. Finish. Okay. Let's say current focus O2. Um, right now, I need to kind of get back on track because I have I've gone like way off course from what I was doing. So currently, in the order that I'm hoping to follow, actually, I just realized something. You guys cannot see. Yeah, there it is. In the order that I'm hoping to follow, currently, what I want to do is finish learning Zola. I'm not going to touch Dioxys for now. We need to finish learning Tokyo. Then we need to jump into Ractor because I have some ideas for things that I can do using an actor framework. I'm kind of glad that I explored this concept. I'm kind of glad that I not even explored. I'm kind of glad that I was introduced to this concept in the first place, because this is a different way of doing things. This creates a sort of higher level where you have these entities that are meant to handle various tasks. So it essentially sets up a task management sort of system for you, which you would otherwise have to set up yourself if you wanted to create an agent based or actor based kind of thing. It's less about the actor thing itself. It's more about being able to delegate tasks to various different entities, which in this case they're called actors, and then have them, do their work based on certain rules. So we need to explore Ractor. After Ractor, I was supposed to explore this thing called Auto Agents, I believe it was called. This is a Ractor based um, AI agents framework written in Rust. So you can use it to create AI agents. Um, Hold on. So let me make this as a maybe. What was it called? I think it was called Auto Agents. Huge maybe. Not necessary right now. Okay. Now, after this is done, after Ractor is done, we need to look into Redis. Um, After Redis, we need to go back to, okay, so then there was Nano as well. Um, at some point, we have to get back to data science and also get back to deep learning. Um, Hold on, there was something in between. Yeah, the AI voice app, Onyx. I need to look into Onyx. There were a couple of things that I needed to look into. So we have Redis. Redis is necessary for the AI voice app. Yeah, so stream AI voice app. This is our current list, and holy shit, I have kind of deviated from the original path quite a lot. The original path was these two things, and now we have a bunch of these other things. Um, Game dev and VTuber app. Yeah, okay. Later on, I can like delete these and like or reorganize them, make some of them children of the others, and make some of them like basically make it like a branched out kind of thing. So I mean, then we have Tokyo Reactor, but currently it has to go in this sort of. Oh, I was also gonna do a live VFX um, thing with Nano. Okay, speaking of Nano, by the way, so it's kind of interesting. If you look at like I was initially I was having a very hard time deciding which framework I wanted to give my time to, Nano or Bevy. These are two very different frameworks. Nano is Nano is a creative coding framework, and Bevy is a game engine. These two are not at all the same thing. They're both meant for two very different purposes. You can use them for um, the other purposes as well. So you could use Nano for game dev. You could also use Bevy for creative coding. But these two are meant for different purposes, and so their APIs are structured in that way. The various tools that they offer, the various workflows that they offer, they are structured considering the goal that they were designed to accomplish in the first place. And the reason I kept trying to decide between the two was because I wanted something, because I don't want to be learning multiple frameworks for multiple different things. I'm already doing that. Like over here, you can see this list of stuff. But like this, there's a reason, because each of these frameworks accomplishes a different thing. But in terms of graphics, if it's something about displaying graphics on the screen, and all of the extra systems and stuff that that framework allows you to build, not built, um, the extra stuff that the framework allows you to build, and the graphics and whatever other features come along with. Where was I going with this? Yeah, in terms of those things, I want to pick one framework that I can use for most of those things, because um, these are both. I mean, especially something like Bevy. It's a big framework. It's a continuously evolving framework. It's a very actively developed framework, actively maintained. Like there's a community centered around this. There's a community built around this, and there's also a community built around Nano. Now, here's the thing: initially, when I had looked into Nano, something that concerned me was not seeing a whole lot of commits there. Actually, it'll be better if I show it to you guys. I can. I need to bring up that page. But yeah, okay. While I'm doing that, I can talk. So something that concerned me initially was not seeing a whole lot of commits, or recent, I should say, not seeing a whole lot of recent commits on the Nano repo. So I was like, okay, is this framework actively being developed, or like what's the situation here? And initially, I was going with the assumption that, okay, maybe they've accomplished all that they wanted to with this framework, and the thing is, it's built. There isn't too much more left to add. So maybe that's why. As in, I wasn't even sure if there isn't too much. There's definitely more that can be added if they feel the need to, but like maybe they've gotten to the point where they feel satisfied with the framework and it is accomplishing whatever it was supposed to accomplish. So maybe that's why there isn't that much development going on it. But that wasn't the case. It turns out that the main maintainers, um, who were actively developing this framework, they over the past like 2 or 3 years, they've gotten really busy, and they are unable to give time to actively developing this framework. Actively developing this framework involves a bunch of stuff, like in the back end, stuff that we as the users of this framework may not necessarily have to concern ourselves with. But the devs who are developing the framework do have to concern themselves with it, because, that is what gives us that luxury of not having to concern ourselves with it. So there's a lot of stuff in the back end that has to be developed and maintained, and in case if there's any sort of breakage, when it comes to interfacing with other libraries, when it comes to um, adding support for, or rather maintaining support for other libraries, because there are a bunch of other libraries that are uh, whose functionality is being used in Nano, just like how a lot of other frameworks are. Like not everyone builds every single thing from scratch, because when you have a bunch of functionality already being maintained, then why you're gonna do the entire thing from scratch. Wait, give me a second here. Yeah. So, um, well, okay. The point is, wait. Let me finish looking this up. Nano Bevy. Uh, Bevy plugin rework, and then there was another. Um, hold on. This issue tracks Bevy plugin rework. This is a GitHub project that they set up. Let me just open that up so I can read out the entire thing for you guys. So the gist of it is that the Bevy devs have decided to start moving the development of Nano towards being more of a plugin for Bevy. So it's going to be essentially built on top of Bevy. It's going to be using a lot of Bevy's own tech, and this way the devs can still maintain that creative coding. Wait, yeah, this way the devs can still maintain that creative coding style um, that Nano allows. And where was I going with this? I think what I was saying was this way the devs can still let Nano be what it is on the higher level, but on the lower level, instead of the devs having to implement a bunch of things manually and having to add in a bunch of functionality from other crates, the entire thing can just be built on top of Bevy because Bevy already has a bunch of the tech that Nano is using in the backend. So like the problems that Nano is trying to solve, not problems, but like the tech that Nano requires in order to be able to be Nano. Bevy has already solved a couple of those problems. Bevy already has tech in place to kind of support those things. So the devs feel like they can move Nano from being its own separate standalone framework to being a Bevy plugin, which allows developers to choose whether they want to use, like, depending on the application that they're trying to build, do they want to build a game using Bevy's own API, using ECS and stuff, or do they want to go the creative coding route and use Nano's API instead, because the way of doing things in Nano and Bevy is completely different. Bevy is completely ECS based, so everything that you want to do, it's going to have to be through the entity component system. You create entities, you create components to attach to the entities, and then you create systems that operate on various archetypes or various entities that belong to certain archetypes. That's the idea behind ECS. Whereas with Nano, it's more, it just gives you the freedom to draw whatever you want on the screen. So these are two very different approaches for displaying graphics on the screen. And I'm gonna be honest, this kind of gave me some hope. Okay, this says this is in progress. This says this is ready. I don't explore this part of GitHub as much, so I don't know too much about it. Oh God, why are things slowing down? Initial discussion. This is the discussion. Okay, I was trying to open this up. My God, why is that so slow? Holy shit! What are the components that are being used here? Well, to be fair, my own system as well. It's kind of slow. Dude, there's another project that I wanted to. Hold on. There was something more I was gonna. Apart from this list that I just made, there was something else that I was supposed to write down, which I completely forgot about. Um, Give me a second here. Let me open up my chat on my phone. I can't remember what it was, dude. Oh, yes, yes. Good thing I remembered. Hold on. Um, how do I wait? What should I put this into? After stream tutorial. How did it say? Oh God, I haven't touched this in a while. calling app.run in textual. I haven't touched textual in a while, which is crazy because I was gonna do like TUI stuff in Python, but then I'm like, at this point, I don't know if I'm going to do TUI stuff in Python. I still might, but like, I don't know. I'm aiming more towards Rust, because like I don't know. I feel like if there is gonna be TUI involved, it's probably best to go the Rust route with it. I can do it with Python, but like, do I really need to do it with Python? I'm not sure. Yeah, you know what? Okay, we'll do it based on need, because currently there's no need. I feel like that's a good yeah. Wait, setting up a VTuber like setup using terminal and maybe T. Okay, this is probably not going to happen because now I'm doing Nano, and then we can get rid of this as well, whatever that was. Actually, I think hold on. Um, how to disable IPython History Manager to prevent sharing code suggestions across projects. Oh, I think I already handled this. There was a setting that I had to change in one of the IPython settings files. It was like a global setting kind of thing that I had to do. I forgot what it was exactly. Yeah, yeah. But I did this already, and I think I already made a, what do you call it? I think I already made a, just a second. Yeah, I think I already made a post about it. Yeah, I think I already made a, not a post, but like a journal entry about it. I don't remember. Also, there's this thing that I'm trying. Oh, yes. Okay. Good thing I remembered it. Hold on. So, current focus. In my current focus, we need to get back to HF transformers, because there's a specific, well, there's a bunch of things that I want to do with it, but um, Hugging Face Transformers makes it easy to use a bunch of the libraries that are, not libraries, a bunch of the models that are available. Hugging Face Transformers itself is a library, but yeah, Transformers makes it easy to use a bunch of the models that are um, available on Hugging Face, and additionally, there's a bunch of models that are also implemented within the Transformers library, and these are also models that are available on Hugging Face, that are being hosted on Hugging Face. If there is official support for the library, why do I keep saying library? If there is official support for a specific model in the Hugging Face Transformers library, usually when you go to the models page on Hugging Face, you're gonna find, um, I think it was under deploy this model, or there's a button. There's a button. I think use this model or something like that. There's a button that you click that expands, um, and gives you details about how you can use this model. I think it's just called use this model. So you click on use this model, and then, or whatever similar thing. I can't remember exactly what it's called, but you click on that, and then it's gonna pop up a small window kind of thing, giving you information about how this model can be used in various ways, not just one specific way. If there's only one way, then there's only going to be one way mentioned there. But if there are multiple ways, then those multiple ways are going to be mentioned over there. Especially if there's transformer support, it'll directly mention exactly how you can use transformers. Okay, this is interesting. Um, Okay, okay. Anyways, right. I think it was just gonna be content clipping bot. Let's say that content clipping bot. So there's this idea that I had, um, where I wanted to. There's this idea that I had where I wanted to try and use AI models to essentially generate clips out of my stream VODs, and that way I'll have a quicker way of generating content out of my own VODs, so I can post it on social media. But I wanted to, like, this would be an interesting experiment, an interesting way to practice the usage of models. This would be an interesting, let's say, experience, I guess, because I would have to use multiple different models for various purposes. It's not as simple as just taking uh, one model, one Uber model, and just feeding the VOD into it, and it'll spit out the information. I'm sure there's probably some paid model out there that some company has built, but I'm not looking for that. I'm looking to do it with open source models, and where was I going with this? Yeah, I'm looking to do it with open source models. And because there isn't currently a sort of Uber model that can do that one thing, so instead, I need to divide that task into multiple smaller tasks, and accomplish the goal in that way. So there were a couple of different ideas that Gemini gave me. It was like, okay, so the main idea, like the final goal, is to have clipped segments, or at the very least through the models have specific timestamps that tell me which segments I need to clip, and then I can use a library like FFmpeg to split up the VOD into multiple clips. But I need the timestamps. So there's various types of analysis that can be done on the VOD in order to decide, hey, this clip could be interesting, this clip could be educational, this clip could be funny, this clip could be XYZ, whatever. So there's a lot of interesting stuff that we're going to be doing once we start working on the content clipping bot. I need to decide if I want to do that in Python or in Rust, because speed isn't necessarily what I'm looking for there. Because there's going to be a lot of work. There's going to be multiple levels there. So I feel like doing this in Python would help me out a lot more. Yeah, I think so. Because in terms of using the Hugging Face Transformers library, I could use the Candle Rust crate, which does have a bunch of HF Transformers functionality. I don't know if it has like all the functionality. So if there's like a one-to-one thing between HF Transformers and Candle, they're both being developed by Hugging Face. They're both Hugging Face libraries. It's just that Transformers is a Python-based library and Candle is a Rust-based library. I don't know if they both have the exact same features. Um, However, something else to keep in mind is that doing it in Python is going to make things a lot less hectic for me because of Python's concise syntax. It's going to make things a lot less hectic for me. And if speed ever becomes um, an issue, then we can bring Rust into it. I like that idea. I like that idea. You know what? Keeping that in mind, So, okay, we have, I don't think I ever looked into async IO in Python. Python async. So there's the async functionality in Python by itself, right? But then there's also async IO, which, hold on, let me just read this. This is managed by an async IO event loop. Oh, async IO is part of the standard library. Okay, my bad. My bad. For some reason, I thought it's separate. Async IO is a library to write concurrent code using the async await syntax. Right. Okay, great. Awesome. So this is one thing I need to look into. Right. So here, this is going to be Python. This is going to use HF transformers. Um, async. Actually, let me be more specific. Async IO. And then there's another very important thing that I want to add into this. I want to see if Python has an actor framework. Okay, Python actor framework for heterogeneous computing, or heterogeneous. Let's say heterogeneous, whatever. And then there's something called Pika or Pika. Pika is a Python implementation of the actor model. Which one of these is more widely used? Let me look at that. So one is called X Oscar, and the other is called Pika. Let me open both of these. Oh, yeah, before I forget, there's another Rust project that I want to work on, and I kind of want to do this like soon. Um, what should I call this? Um, this is okay, this is specifically for freeing up memory. This is like a very specific use case. I have a very old machine on which I watch Twitch, and the machine is running Ubuntu Studio, and it's not using a desktop environment. It's using the i3 window manager because I wanted to try and make things as lightweight as possible. And if I had the desktop environment, then there's a bunch of extra stuff that gets loaded, which just kind of bogs down the system. This is an old system. When I say old, I mean like a dual core CPU, and 2 GB of DDR2 RAM. Like that's how old this is. This hardware is like close to 2 decades old at this point. Um, it still works though, so I wanna run it as long as it runs. And just a second. Okay, so wait, yeah, okay. Now, um, the point is, I have situations where I need to, because I'm primarily using this to watch Twitch and Netflix. Those are the main two tabs that I ever load, and rarely I'll open up YouTube in a separate tab. At any given time, I can only have one tab open, because that's how little memory is there in the system, and it works. Like for example, I have Fillion's stream running right now. Um, but every now and then I have to sort of unload the tab. Like after the tab has been active for a while, I have to unload the tab, and then I can reload it again and things are fine. Up until that point, like once the tab has gotten to the point where I need to unload it, things are going to start to become sluggish. So the mouse cursor movement is very slow and jerky, and even just moving the mouse is slow. Trying to right click, it takes time for the that menu to pop up and all of that stuff. So my idea was to just crash the tab every, I don't know, 1 hour or something, every half an hour or 1 hour. And once the tab crashes, I can just refresh and restart the whatever it is. And I want to do this using a Rust program. It has a very specific purpose, so I don't think I need to. Dude, there was that. What was it? What was it called? There was a task scheduling program in. There was a task scheduling. Um, what do you call it? What do you call it? Crate. There was a task scheduling crate in Rust that I was supposed to be learning. Rust task scheduler. Was it Clockwork? I don't think it was called Clockwork. Oh, I think it was Tokyo Task Scheduler. That's what I was. I think that's what it was. A non-blocking task scheduler for Rust. This library provides a flexible non-blocking. Dude, okay, this is another thing that I could look into because um, creating a task scheduling system that also tends to be a bit of a headache unless you want to do like a very simple loop kind of thing. But if you have like multiple tasks that have to be executed at different times or at different intervals, or maybe even repeated or stuff like that, or done based on different conditions and stuff, then things get a little bit complicated. So I was going to look into Tokyo Task. This is so hard to say. Tokyo Task Scheduler. My God. I'm just going to say TSS. Um, oh, also, yeah, this is the program that I need to write. Firefox tab closer. Just I'm thinking too hard about this. Um, I need to learn Tokyo Task Scheduler as well. Then there's Redis as well. I don't think we're gonna do auto agents. I just noticed that I misspelled agent. I wrote agents. But anyways, yeah, I don't think I'm gonna be doing that. I'm definitely gonna do a Ractor. And oh yeah, I was looking at actor frameworks for Python. So we have Pika or Pika, and we have X Oscar. Both seem to be actively in development, but it seems like Pika is um, a lot more famous. And it says Pika makes it easier to build concurrent applications. Pika is a Python implementation of the actor model. The actor model introduces simple rules to control the sharing of state and cooperation. What did I just do? Okay, yeah, to control the sharing. Actually, I could open the thing up here. Oh, we were looking into this. I forgot about that. We were talking about Nano. How long have I been streaming? Holy shit. We are like 39 minutes into the stream. That's crazy. That's crazy. Okay. Um, Wait, real quick. I had actually kept some potatoes for boiling, so I'm gonna check. I'm gonna go check up on them. Though, I mean, yeah, yeah. You know what? It's been like an hour maybe. So um if it needs more water, then I'll put more water into it and then come back. Or I could just turn off the flame because I'm pretty sure the potatoes are cooked. And because I'd kept it on a low flame specifically because I was going to be streaming, so I was like, I don't want the water to, run out very quickly and then the entire thing burns. But yeah, give me a second. I'll come back. All right, I'm back. Okay, so let me open up. Let me open up Pica here on this machine. First, let me take a look at their documentation. Okay, getting started. The actor model, message passing actors, actor proxies. Learn about the actor model concepts and rules that Pica is based on. Yeah, okay. Pica is a Python implementation of the actor model, which is a model that treats message passing actors as the basic building blocks of concurrent computation. Right. So, why was I thinking of doing this in Python? What exactly was I going to use this for? I can't remember. Actually, okay, while I'm thinking about that, I can load up. Oh shit, we were supposed to be reading up on Nano. I might as well just rename this stream because I think we're just going to be looking into um, this stuff that I'm currently looking into. We are probably not going to be doing any Zola um, work, any Zola studies. That's fine. I can rename the stream after the stream. Okay, Pica. Okay, there's the repo, there's the documentation. Okay, awesome. Just a second. I should have kept this low. All right, are we good here? I think, yeah, yeah, we're good. So I can transition back. Now, why exactly was I looking at, why exactly was I thinking about actors for Python? What was I doing in Python that was going to be using actors? Yeah, I don't remember. Though, okay, for this Firefox tab closer, um, we could have a simple implementation. Since this only has to do one specific thing. Um, every, I don't know, we could say 30 minutes. I can change that if need be. Or okay, so we can do it like this. Every X minutes, back up. Why am I, yeah, simple implementation. Every X minutes application wakes up and um, checks the current running the oh checks the current running processes to find the oh actually okay there's a library. I forgot what the library is called in Rust um, process library. Okay, there's standard process. This is a module for working with processes. That's not what I'm looking for though. I think it's this one. Rust PS util. I think this is the one. Um, a process and system monitoring library for Rust. This is, yeah, this is the one. This is what I was looking for. Because I needed something that can give you information about processes. Um, the name is the least of them. At the very least, it has to give the name, but also a bunch of other information like how long the process has been running, how much memory the process is consuming, and a bunch of other very useful information. Basically, a lot of information that you could find, well, not a lot of it, but like some of it that you could find by looking at a task manager, or looking at a process monitor like BTOP. I want to get that kind of information programmatically instead. And the idea is every 30 minutes, the program is going to wake up and it's going to check. Actually, okay, I don't think. Yeah, okay. It could be every 30 minutes the program wakes up and it checks which, yeah, it checks which Firefox process has been running for the most amount of time. And of the processes that have been running the longest, so like let's say an hour maybe, of the processes that have been running the longest, which one is currently consuming a lot of memory, and it'll then crash that process. Actually, I just realized something. This application would need to be shut down when I'm sleeping. Yeah, this application would need to be shut down when I'm sleeping. Otherwise, it's gonna crash. It's gonna crash the tab on its own. Yeah, so this bit of automation might not always work out that well. Okay, you know what? I can look into this later on. For now, we can get rid of this. And here is Pica, and I also loaded up the repo. This is the repo for Pica. Now, before we continue here, let's read this, the nano thing. Okay, so one of the devs writes, "Hi folks, just wanted to start with letting you know I really appreciate your concern for the state of Nano. It means a lot that some peeps have found use for it and care about it and care, oh, hold on, and care about its direction. A huge thanks to so and so, so and so, so and so for doing some deep diving and getting to the bottom of the recent EGUI breakage." Okay, all right. As is obvious, so and so and I have found less and less time to tend to Nano over the past year or two. In the past, we've been able to use our mind buffer contract work to guide forward progress on various features. However, our more recent software contracting work has left a little less time for playing with lasers and graphics. We've been chatting about how we can make better use of our time that we do get for Nano and wanted to share some thoughts. One of the more tedious, time consuming aspects of Nano maintenance is maintaining the compatibility between WGPU, uh, Winit, and UI dependencies. So, this is what I was talking about when I was mentioning the tech that powers Nano. Like a lot of the other tech that Nano is using for UI stuff, it uses EGUI, and for windowing stuff, it's probably going to be using something else. For graphics stuff, it uses WebGPU, which is done through WGPU, stuff like that. Okay, continuing. And more generally, the upkeep involved with custom application event loop, with the custom application event loop, window and graphics wrappers. Back when we kicked off the project 7 years ago, there weren't many libraries tackling this sort of work, but since then a lot has changed. Nano Bevy plugins. In particular, Bevy has caught our eye recently. We've been doing some experimenting with it over the past few months, and we are thinking it could be a good candidate for taking over some of the heavy lifting previously mentioned. It has multi-window support, supports all platforms Nano already does, provides a more flexible plugin framework atop the ECS design, and has grown a huge community with some healthy funding. I already it already has support for many features that Nano is lacking, like mobile targets. Oh, mobile targets. Okay. Headless modes. True, true. Bevy does give you that option. Custom event timers, and there are plenty of examples. Give me a second. I just realized I'm having trouble reading this because it's not zoomed in. Right. This should make it a little easier. Okay, perhaps we can leverage Bevy's existing application slash events slash windowing slash audio support to allow us to focus on providing the high level fun stuff and reorient Nano towards providing a suite of creative coding focused Bevy plugins. These might include Nano Draw, Nano Laser, Nano OSC, Nano WGPU, and Nano ISF. ISF support, though we might want to reconsider it in favor of the WGSL focused approach. Okay, for those who appreciate Nano's processing inspired API, we could consider stripping down the Nano crate to be a simple wrapper around Bevy and the hypothetical Bevy Draw plugin or Bevy Nano Draw plugin. This should allow us to remove the custom application loop, the window wrappers, the simplified event types, and hopefully only require minimal changes to the example. This approach won't entirely remove the aforementioned churn involved with the WinIt, WGPU, EGUI updates, etc. However, we'd at least like to be able to we'd at least be able to share that load and collaborate upstream with the larger Bevy community. Maintainers welcome. Okay, all right, okay. Then a bunch of people gave their opinions on it. They dropped information that they had, and this discussion was started at the end of 2023. So since then, they have been making a bunch of progress. So this is kind of why I was like, okay, what should I focus my efforts towards? Because it does seem like Nano is going to be shifting to Bevy, but it's not like the entire thing is going to be lost. Um, Nano is just a different way of, Nano is a much different way of coding than Bevy. Um, because again, Nano is meant for creative coding, not not necessarily game development, but it could be used for game development if you wanted to do that. While Bevy is not necessarily meant for um, creative coding, it's more for game development, but you could also use it for creative coding if you wanted to. See, as I'm reading this and as I'm saying this, I'm still wondering if I should be putting some time into Bevy. It's just that, dude, I liked the way that things are done in Nano. I really like the way that things are done in Nano. And I'm guessing like if Nano does move to Bevy, um, I'm sure they would do a bunch of work to make it so we don't have to, how do I say this? They would make it so there's the least amount of friction for developers who are used to the nano style of coding and who want to remain in that nano style of coding. Because as I mentioned before, Bevy and Nano, they have two very different purposes, and they both also have very different coding styles. Um, Bevy Bevy just lets you draw things on the screen. You have like a model view update loop. I forgot what exactly the thing is called, but it lets you control like frame by frame what's going to be drawn on the screen. With Bevy, you're right out of the box. You're using the ECS system. Well, you're using the ECS, the entity component system. Oh, you're using the ECS architecture. That's what I should be saying. You're using the ECS architecture out of the box because that's what Bevy supports out of the box. And the idea there is you create entities, you create components that are basically data. Then you attach those components to those entities, and different component combinations are called archetypes. So then you can write systems that operate on specific archetypes. Oh, give me a second. I forgot something. Uh, do that, and okay. So, yeah. Oh, you know what? Okay. Did they mention Bevy? Okay. Bevy engine. Let's open that up. I want to look at the yeah, dude. Okay, I'm definitely curious to see what direction the devs take Nano in. I need to explore this whole project thing because I don't look at like the project feature on GitHub as much, so I don't really know how that whole thing is being operated. I mainly know that okay, if there's something special being done or a certain feature is being worked on, then there's a separate branch for it. You know, like very basic GitHub, very basic Git knowledge. Um, so I'm gonna look for a specific branch on which they're working. The thing is, if I'm gonna be exploring that side, then I feel like I need to learn the basics of Bevy first, in order to be able to understand exactly what that is doing. Because the idea there is that because okay, with Bevy, well, okay, the idea with the direction Nano is currently going in is that they want to turn Nano into one of the Bevy plugins, or there can be multiple. Actually, I think it's multiple Bevy plugins. They're probably going to make it modular. I'm not sure. Either way, one or more Bevy plugins. The idea is that it's going to be one of the plugins, and plugins are basically what add functionality to a Bevy app. You can choose to have or not have specific plugins, and this is where they were also mentioning the thing about being able to run in headless mode or being able to have multi-window support. Headless mode is basically you have Bevy running, but like there's no window or UI or anything attached to it. It's just Bevy running in the background. It's doing something. It might be accomplishing some kind of goal. There might still be some kind of game being played. Um, maybe it's running a server, a game server of some sort, so it can be a headless server without any need for like UI or anything, and you can do everything through your terminal. Or maybe you could use the headless server for something else, but that's one example. Hold on, let me show you guys here. So that's why I'm wondering, like, okay, maybe I could spend some time learning like the basics of Bevy, and then I can decide if I want to, like what direction I want to go in. Because the thing is, I was planning on on looking into a bunch of. I was planning on adding like a bunch of extra functionality. Hold on. Yeah, I was planning on adding a bunch of extra functionality to Nano. Like for example, if I'm working on a game, then I would let's say if I wanted to add physics simulation, right? Collision detection, rigid bodies, and stuff like that. Then I was planning on using Rapier. So I would have to integrate Rapier into my application, right? Bevy supports that like out of the box. Bevy already has that integration, and there's a bunch of other examples of stuff that Bevy is able to do like right out of the box because it has like the features. Let me hold on. Uh, let's open up the Bevy site again. Maybe there's a features section. Okay, right. Okay, we have the brochure right here. So it says it's data driven. All engine and game logic uses Bevy ECS, a custom entity component system. It's fast, massively parallel, and cache friendly. Simple components are Rust structs, systems are Rust functions. Then capable queries, global resources, local resources, change detection, lock-free parallel. Okay, so I don't know enough about the ECS architecture to be able to appreciate what this is saying, but I get the other stuff. Then 2D renderer, render real-time 2D graphics for games and apps. Features: sprite sheets, dynamic texture atlases, cameras, textures, and materials. Extensible with custom shaders, materials, and render pipelines. Common core builds on top of Bevy's render graph. Okay, then actually I should see. I should see. I believe Bevy also supports WGPU. I believe Bevy is also running on the web GPU backend. Let me see if they have. Oh shit! Too much zoom. Um, I love that even after all this time, they still have this message. Bevy is still in the early stages of development, which technically it's still true. It's like still because this is a game development framework that doesn't yet have an editor. Like that's how that's I don't know if that's really the best way to say that. Oh yeah, this is very early in its stages, but I think yeah, that's I think that tells you that it is still in its early stages. That being said, there is development being done. They are currently working on an editor, um, and this is something that I really liked. They had mentioned this in the philosophy for that editor. They have an editor manual kind of thing. Well, they have documentation that they wrote for the effort that is being put towards building the editor. I should say it in that way because saying the editor manual makes it seem like there's already a documentation manual for the editor. No, this is documentation for the development of the Bevy editor. They were mentioning a bunch of things in there, and one of the things that they mentioned, which I really liked, was that they want to use Bevy as much as possible to make all of the Bevy functionality. So they want to we have the Bevy engine itself, the Bevy framework itself. They want to build the editor on top of the Bevy framework so that the editor itself is using Bevy. We're not using some other framework or even worse, some other language in order to build the editor that's going to be uh, that's going to be used to build Bevy games. I don't know if I explained that very well, but yeah, the idea is that they want to use Bevy to build the Bevy editor. Um, where do they like? Do they mention the backend somewhere? I don't. Dude, I'm still like kind of torn between both of these frameworks because like on one hand I do want to do game development as well, um especially after after recently starting gaming back up again. How do I even say that? After I recently started playing games again, um I'm a lot more motivated to, you know, make more games. I'm a lot more excited to make more games, or at the very least, not even like full-fledged games, just prototypes, even if it's like silly prototypes. Oh, sorry, I was watching something and got distracted. Okay. um dude, I think they did mention somewhere here web GPU. Can't remember where that was. Maybe if I look at the renderer. Actually, yeah, that's a good idea. Maybe it's under crates. Right. So what is it called? Bevy renderer, I guess. Let's look for that. PBR, okay, platform, so and so, so and so, so and so, Bevy render. There is nothing on it. Let's take a look at cargo Tamil. Right, web GPU is mentioned here, though. I think there might be more than just web GPU support. Yeah, I think there might be a little more than just web GPU going on. I think I need to have a conversation with Gemini about this. Okay, that's fine. Um, where was I? Here. All right. Okay. So, moving on with this list, a modern and flexible 3D renderer. Okay, lights, shadows, cameras, meshes, textures, materials, GLTF loading. That is useful. GLTF is a pretty. It's well, I want to say it's a pretty famous format, but it's like slowly over the past couple of years, it's been slowly, you know, gaining more and more traction. Um, it's surprising that it took so long for it to gain traction because it's a really useful. I remember I wrote a GLTF importer for Unity a while back. Mine was very basic though. It was mainly for one object. It was limited to just one object. But in doing that, the I got to learn about the GLTF format. So that was interesting. Like I got to learn how exactly data gets handled, how data is organized within the format. Like you have a scene, within the scene you have like multiple objects, and when you're talking about a certain object, there's different properties of that object. How do the properties get like distributed amongst within that entire structure? You get to learn all of that. It's a pretty decent format. Actually, I feel like in terms of writing a scene, writing a writing an editor that can do something that can help you set up a scene, I feel like the GLTF format can be used for that. Though it doesn't necessarily have to be specifically GLTF based, it just has to be designed in such a way that it could eventually be saved to GLTF, but it doesn't also have to be GLTF. It could be some other format as well. Because I'm sure there are other formats that are more that are more meant for saving a scene, but GLTF does allow you to save entire scenes. So because it's not like when you export the thing, you're not just exporting the object. If you look at the, at least from what I remember, you're not just exporting the object. If you look at the data that's being exported, the object is within a scene, so it's a scene that's being exported. Okay, where was I? Okay, yeah, built on top of Bevy's render graph. And then here's the render graph. Compose custom render pipelines using a graph structure. Parallel render graphs are automatically rendered in parallel. Modular, build composable and reusable render logic using render graph nodes. Backend agnostic, not tied to specific graphics APIs. Okay. Well, I feel like that's where WGPU comes in, right? Because WGPU gives you the option to like target different APIs, but using one fixed graphics API. Anyways, moving on. A capable animation system. This is another thing that I was planning on adding. Not specifically this kind of animation, but like animation of some sort, animating something, basically. Uh, Maybe it could be animating specific properties or animating something, like something changing over time, basically. Right. So for that, I was going to need to add a separate crate into Nano if I was planning on doing it with Nano. And this is what I'm talking about, like a bunch of stuff that I was planning to add into Nano, into my Nano application. A lot of that is already part of Bevy, and now that I know that Bevy, not Bevy, now that I know that Nano is slowly moving towards becoming a Bevy plugin, I need to, okay, I feel like I should do more research on, I should read up more on that project and see their progress, how their API is developing and what changes are going to be there, how things are going to, how things are going to change. Um, and how things could possibly move away from their current coding style, which, from what I understand, the whole idea is that they're trying to maintain the current coding style because that's what's a lot more fun. That's a very different way of coding graphic stuff compared to how you would be coding it in Bevy. That's not to say that one is good and one is bad. They are just two different styles, and each of them they serve different purposes because Nano was initially meant for something else. It's still meant for something else. Bevy is, well, it was and still is meant for something else. One is for creative coding, one is for game development. With game development, you would want more structure and you would want to build systems. You would want to worry about performance. Uh, you would worry about performance. What's the word, performance friendly. You would worry about performance, basically performance impact. You would worry about how how performance friendly the entire thing is. You want to make it as efficient as possible, right? With creative coding, so this was with game development, right? With creative coding, you don't necessarily always give a shit about that, um, because having to worry about that would kind of get in the way of creativity. And the whole idea behind Nano is that it's a creative coding framework that just allows you to draw stuff. You could make things structured if you wanted. You could make things performance friendly in your own way, but the whole idea behind Nano is that it lets you just draw stuff. So that's kind of why I'm like, I need to see, what the differences are going to be between the current Nano and once Nano becomes a Bevy plugin, because I kind of like the idea of I because I've explored Bevy's no, I've explored Nano's coding a little bit, um, tiny bit, just written like a very basic application, and I kind of liked the way things were being done there. Um, I like that style of coding. I like the API, the workflow that's being followed there, especially for like creative coding stuff. If I want to, for example, build a VTuber application again from scratch, um, I could just I could build it really well. Okay, I'm not going to say I could build it really quickly, but if I want to build anything, not even a VTuber application, just like anything silly that I wanted to build, any silly idea that I had for any kind of animation or something, I could just implement that very easily in Nano. But if I take it to the Bevy side, then I have to make the entire thing structured because it's ECS. So I have to find a way to accomplish what I'm trying to accomplish using the ECS architecture. Now, on the other hand, the ECS architecture would be very useful for games. If I was working on a game, then it would be super useful for that. I kind of I'm getting the feeling that okay, even though I wanted to avoid getting into both of the frameworks, now that I know that Nano is eventually gonna become a Bevy plugin and there's like it's gonna be integrated with Bevy, now I'm wondering if I should take the time to learn, at the very least, the basics of both of them. Yeah, I'm really curious about that. I'm really wondering about that. Okay. Anyways, carrying on. So it supports animation, skeletal rig animation driven by an ECS based joint API. Oh, okay. This is another thing, right? Bevy has support for a bunch of other crates. It has a bunch of features added into it through outside crates, through integrating outside crates. Like, for example, Rapier, there's a Bevy plugin for it. I think there's a separate Bevy plugin for the 2D version of it, and there's a separate one for the 3D version of it. There are other examples as well. And then on top of that, you've got these kinds of systems where like they've built their own systems. I don't know to what extent it's all from scratch, but like there are certain situations where they've built their own systems for various purposes. So you get like a bunch of different tools if you're using Bevy. Bevy UI, a custom ECS driven UI framework built specifically for Bevy. Built directly on top of Bevy's ECS, renderer, and scene plugins, compose UIs dynamically in code or declaratively using the Bevy scene format. Use a familiar Flexbox model to lay out your UIs. Then scene. Create, save, and load ECS worlds using Bevy's scene system. I should keep this in mind because I was planning on making my own editor sort of thing. Hot reloading. Changes to scene files are automatically applied to running apps. Sound. Load audio files and play them on demand. Load audio files as assets. Play audio assets using audio entities. Hot reloading. Get instant feedback on your changes without app restarts or recompiles. Asset changes are immediately reflected in running Bevy apps. You can currently hot reload scenes, textures, and meshes. Any asset type can be integrated. Then productive compile times. Game development is an iterative process. You can't afford to wait for compiles. Yep, I have good experience with that working with Unity back in the day. With Bevy, you can expect zero point 0.8 to 3 seconds with fast compiles configuration. Compare that to other Rust game engines, which can take over 30 seconds to compile a single new line insertion. Free and open source. An engine. Wait, they never mentioned the physics thing. I know it has physics features through Rapier, of course. Anyways, an engine made by and for the developer community, 100% free, forever and always, open source under the permissive MIT or okay, that's the license. No contracts, no license fees. I like that. No sales cuts. Okay. Yeah, they didn't mention oh, this is great. This is what they were talking about with the funding. And I like that they're open about all of this. They're open about the support that they're getting, and they're also mentioning the donors. But yeah, so okay, now how do I want to go about this? I'm still like kind of because I want to explore nano. Like I want to explore nano. I looked into nano and I liked what I saw. So I don't want to like I don't want to miss out on the opportunity to explore that. Like at the very least I want to explore it and and get an idea of it. And then I want to also explore Bevy and get an idea of this. But like the thing is, eventually Nano is going to be moving to Bevy. So I feel like at that point, I can't really avoid Bevy. Not that I was trying to purposely avoid, well, to a certain extent I was. But like, not that I was trying to avoid it because I hate it. It's just that I don't want to be learning two frameworks. But like, it seems like uh, it seems like eventually Nano is going to be sitting on top of Bevy while still maintaining its coding style, but using Bevy's own Bevy's the various tech that Bevy uses. So Nano is going to become like a layer on top of Bevy. So keeping that in mind, if going to be eventually it's going to be coming to Bevy anyways, I might as well, spend some time exploring both of these. And I did actually explore it to a certain extent. Like to a certain extent, it wasn't like very. It wasn't a whole lot of exploration that I did. The great thing is that they have a bunch of examples. They also have this getting started section, which introduces you to very basic Bevy concepts. There's of course the setup, installing everything that's required, and then it goes into details about various things like apps, the ECS architecture, what is a plugin. And this is what I was talking about earlier, that like a lot of the functionality in Bevy is basically a plugin. So you can like decide to not actually, let me read this out for you. This will explain it much better. Plugins. One of Bevy's core principles is modularity. All Bevy engine features are implemented as plugins, collections of code that modify an app. This includes internal features like the renderer, but games themselves are also implemented as plugins. I haven't fully understood that part. I guess I'll understand that once I go deeper into Bevy. That sounds weird. Okay, this empowers developers to pick and choose which features they want. Don't need a UI, then don't register the UI plugin. Want to build a headless server? Don't register the render plugin. This also means you are free to replace any components you don't like. If you feel the need, you are welcome to build your own UI plugin, but consider contributing it back to Bevy if you think it could be useful. This is those not contributed back. Okay, this is talking about like third party stuff. However, most developers don't need a custom experience and just want the full engine experience with no hassle. For this, Bevy provides a set of default plugins, Bevy's default plugins. Let's make our app more interesting by adding Bevy's default plugins, which are a plugin group containing core engine features. For those needing minimal features, minimal plugins exist. Let's see what all is included in this plugin group. Will add all the default plugins for a Bevy application: panic handler, log, task pool, frame count, time, so and so, so and so, so and so, image. Okay, okay, right. Default plugins contains all the plugins typically required to build a Bevy application, which includes a window and presentation components. For the absolute minimum number of plugins needed to run a Bevy application, see minimal plugins. Okay, all right. Okay, right. So, like I was mentioning, it goes into the basics of app or apps, then the ECS architecture, and there's a bunch of code over here as examples. Then plugins, which we just explored as well. There's also a thing for creating your own plugin, which is interesting. And then it goes into resources, which is for adding like assets to your project. I'm guessing that's what counts as a resource, doesn't it? Well, a resource could be anything else as well, but like yeah, images and sounds and stuff, they all would count as resources. Hold on. The entity and component data types are great for representing complex queryable groups of data, but most apps will also require globally unique data of some kind. In Bevy, we represent globally unique data using the resource trait. Elapsed time is a resource. This is interesting to me. Um, though it does also mention globally unique. So I'm guessing that's where like these two different concepts, they kind of merge together because they both are then considered as a resource. So like elapsed time is like one thing, right? And then renderers are also considered as resources. Various assets are also considered as resources, so images, meshes, audio and stuff. I'm gonna have to explore this thing now. Dude, I guess we have another distraction now because now I'm interested in Bevy. Well, anyways, after that, they point you to their examples thing and they mention various other resources and stuff. So once you learn the basics, after that, it's up to you how like what direction you want to go in. Because further from that point, you just start building stuff and exploring the engine. I don't remember where I had read about Rapier being included like out of the box, but I do know it was included. I just can't remember where it was. Um, okay, okay. Let's see if physics shows up somewhere here. Nope. The word physics doesn't even work. Okay, let's try Rapier. Nope, that's not working. Okay. I don't remember how. I don't remember where I'd seen the rapier thing. I remember it being mentioned in the docs itself. I just can't remember where. But yeah, rapier is supported. It's definitely supported. I know that for sure. Um, where was I? Bevy and then default plugins. Yeah. Okay. So here's what I'm thinking, right? So here's what I'm thinking. Um, what was I saying? Yeah. Here's what I'm thinking. I could take some time to explore Nano without going too deep into it, and then also take some time to explore Bevy without going too deep into it, which, well, this tutorial section kind of helps me, you know, helps me not go way too deep into it. Um, yeah, dude, I do need to remember. I need to keep reminding myself that yeah, I still I still have this list, dude. Still have this list. Now I guess we are adding Bevy into this list as well. That being said, here's the thing, right? For various things, like for example, live VFX, I would still probably go with Nano, mainly because of the way that things are done in Nano. Because, like I mentioned before, Nano is for creative coding, Bevy is for game development. Nano has its own style of coding, its own like event loop. Bevy has its own, and Bevy uses the ECS architecture, right? ECS is great. It's very performance friendly. It keeps things structured and all, and that's great. But it's not always the best for creative coding. It doesn't always. It's not always the best for every situation, if that makes sense. Okay, you know what? Keeping that in mind, I should also see if there's a way to do Bevy stuff without ECS. Like, what if we wanted to do stuff without ECS? Because, okay, one of the things that, and I only realized this because I was having a conversation about this with Gemini. Gemini mentioned that one of the things that Bevy ECS helps you solve is trying to do game dev stuff in a very rustic way. Because quite often, if you are not using something like Bevy ECS, quite often you'll find yourself fighting with the borrow checker if you're trying to do simple stuff, um, which would be like if it's stuff that would be relatively simple to do using an OOP approach and an object oriented programming approach. Trying to do that using a data driven approach or without using a data driven approach, that could get a little bit complicated, especially if you are dealing with Rust's borrow checker, because you could have multiple things trying to affect an object, and Rust's borrow checker is not going to allow that. Like, for example, there can only be one owner for a specific variable, right? For a specific value or a specific object. They can only sorry, they can only be one mutable. Um, well, there can only be one owner, but there can only be one mutable borrow, is what I was trying to say. There can only be one mutable borrow. So at a given time, only one thing um, can change a specific value. There can be multiple other things reading that value, but only one thing can actually change that value, right? And there are structures in place that help you. Um, there are structures in place that help you that give you more functionality to do some more higher level stuff, like maybe having multiple owners and stuff like that. But even then, things can get a little bit complicated when you're trying to do game development specific stuff, and apparently Bevy ECS solves that problem for you. I'm going to have to like see practical examples of that, and the only way I'm going to see practical examples of that is if I do a game in Nano and then try and do that same game in Bevy. That's the only way that I'm going to see a practical example of that happening. But yeah, I mean, I could still work on games in Nano as well. It's just that I'm going to have to integrate the functionality that I want myself. Yeah, yeah. Okay, now give me a second here. Um, you know what? I have some stuff to do, so I'm not going to be sticking around in a person's stream. So I'm wondering if I should raid or I shouldn't raid. Um, hold on. I found a stream here. Someone named, actually, let me see if their chat, if I can even access their chat, or is it like follower only or verified account only, or, and in the meantime, let me also scroll for more. Okay. Yeah. Turns out I can actually raid them. I think so. Oh, the person's on AFK right now. This is on AFK. This is on AFK co-working stream with max ads. Okay, they have something else going on here. I'll look for the other person. Um, okay, dude. Yeah, no, I have some stuff to do. Um, no, okay. I think I'll raid this person. Their name is Princess Axie Axolotl. Um, yeah, we're gonna go check out this person's stream. Let me start up the raid. Okay, so That's going to be it for today's stream. I'm going to see what to do off stream because I feel like I need to explore both of these frameworks as soon as possible and then make my decision about like which one I want to go with because I really like the way that Nano does stuff, but then eventually Nano is going to move to Bevy even while maintaining its own coding style, but it's going to move to Bevy, so I kind of need to learn about Bevy anyways. Um, but yeah, that's going to be it for today's stream. So far, we have a good streak going of streaming regularly, and I'm hoping that that continues. So far, so far things are good. But yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.